Welcome to another episode of MrLopezClasses.com. We are going to continue in our book of Introduction to Marine Engineering. This is our chapter 6, the episode number 3. And we are going to continue with the analysis of the components of the propulsion system. In this particular video, we are going to analyze the flange. We are going to analyze the strut. We are going to analyze the stuffing box, the different type of stuffing box, and we are going to verify the procedure to install, to replace the stuffing box, the original traditional mechanical stuffing box for the new one, the PTS stuffing box or the bellows stuffing box. In the strut, we are going to analyze the procedure to replace the bearing, the cutlass bearing, the different type of cutlass bearing. And also we are going to analyze the procedure to install the sinks. The sinks located in between both struts. It's important to install the sinks properly. Alright, and the couplings, the different type of couplings. And with this episode we finish the analysis in particular of each component. In the next coming episode, in the episode number 4, we are going to analyze the procedure to do the alignment of the engine, the couplings, the propeller, the shaft, the rudder, everything together. We are going to start with the analysis of the shaft. The shaft is selected according with the diameter of the propeller and with the material for the shaft. Remember that we have a different type of materials. We have Aqualoy 22, Aqualoy 19, Aqualoy 17, and we have a tubing bronze, we have a stainless steel, we have different type of materials. Depending on the material and depending on the diameter of the propeller, we are going to calculate the diameter of the shaft. The formula to calculate the diameter of the shaft is this formula. In that formula, we have the constant, 320,000, is a constant to convert unit. The shaft horsepower is practically 96% of the regular horsepower calculated before. 96% of the horsepower of the engine. And times the safety factor. The safety factors are the most common safety factors. We have 2 per small boat, small gasoline boats, 2.0. 3.0 for the average yachts, small yachts. For big cruise yachts, we have in between 3.5 and 4.0. And for high performance boats, is in between 4 and 5. But normally, the safety factor that I use in my calculation is 3.0. And in this formula, divided by the torsional strength. There are different types of torsional strength. If you see in this table, depending on the material, the torsional strength in PSI is different. For Aqualoy 22 is 70,000, for Monel 400 is 67,000 PSI, for tubing bronze is 20,000 PSI. Depending on the material, we have a different torsional strength. With those elements, we calculate, with this formula, we calculate the shaft of the propeller, the shaft. Be careful because in the formula is cubic root, it's not a square root. Be careful when you apply, when you use those numbers in the calculator, is cubic root, no square root. All right. This is one way to calculate the diameter of the shaft. But in the next coming explanation, I am going to explain other way to calculate. We are going to use a divisor. We are going to use those divisors. And depending on the material, we are going to divide it. The diameter of the propeller for 14.5 if it's a propeller of 2 blades, or we are going to divide it for 14.0 if it's a 3-blade propeller, or we are going to divide it by 13.9 if it's 4-blade propellers, and depending on the material, if it's tubing bronze or if it's Aqualoy or Monel. And it's basically the diameter of the propeller divided for one of those divisors, and you have the diameter of the shaft. It's too simple. You don't need the previous complicated formula. Don't forget the diameter of the propeller divided by one of those divisors, and you have the diameter of the shaft. That's too simple. I hope you enjoy the next coming explanation about the chaff, the calculation of the chaff, the materials, and the procedure to remove the chaff and replace the chaff. Now we are going to start talking about the chaffs, the different type of chaffs used in the propulsion system. The material for the chaffs are normally Monel 400, and Monel 500. There are other type of materials like tubing bronze, and naval bronze. Those are special alloys authorized for the fabrication of the shafts for propulsion systems. Those shafts are zero corrosive. Those shafts are no magnetics. Those shafts are high tensile strength. This shaft is a special material. If this shaft is bended, I don't recommend try to straight the shaft in a hydraulic press. If this shaft is bended, I recommend replace the shaft. The price of the shafts depend on the length of the shaft and depend on the diameter of the shaft. If you check, those shafts are not expensive. For example, if you check for about 40 feet and 1.25 of diameter, look at the price. It's not expensive. It's for that reason I recommend replace those shafts. Remember that those shafts have a great elastic area. What is the meaning of that? Those shafts can be deformed and they return to the original position. For that reason, if the shaft is deformed in the permanent area, in the plastic area, the shaft never return to the original position. Replace the shafts always. The micrometer is an important tool. You need to verify the diameter of the shaft in order to replace for other one exactly with the same dimension, the same length, and the same diameter. My friends, what happens if you receive a shaft a little longer than the original? Right now, the distance in between the rudder and the propeller is short. And you remember previously I explained what happens if that distance is less than 15% of the diameter of the propeller. Probably when you move the wheel, the boat responds dramatically. Alright? Be careful with that. The procedure to increase or decrease the distance in between the propeller and the rudder is cutting the shaft. This is the only process. The diameter of the shaft is according with the diameter of the propeller. If you remember, in a previous episode, I explained the procedure to calculate the diameter of the propeller, according with the formula for planning hold or with the formula for displacement hold. In order to calculate the diameter of the shaft, we are going to use the following formula. And in this formula, we are going to use the horsepower. This is the brake horsepower that I explained in a previous episode. Is 96% of the maximum horsepower calculated. SF is the safety factor, and those are the most common safety factors. Alright? And ST is the torsional shear. The torsional shear according with this table. Those are the torsional shears recommended for the different type of alloys used for the fabrication of shafts. This is the torsional shear for those materials. And according with that formula, we can calculate the diameter of the shaft. Be careful because in the formula is the cubic root, it's not the square root. Alright? Be careful when you apply the formula because it's cubic root, it's not the square root. Alright, and this is basically the theory to calculate the diameter of the shaft. I know a single way to calculate the diameter of the shaft. If you are in the middle of the ocean, you don't have the tables, you don't have the information about the material, you don't have information about the torsional shear. You can use a simple formula is divide the diameter of the propeller in between 14.5. you divided the diameter of the propeller by 14.5, and this is a good approximation for the diameter of the shaft recommended for that propeller. The majority of the technicians use that formula. They divided the diameter of the propeller into 14.5, and this is a good approximation for the diameter of the shaft. Okay, be careful when you select the shaft. Use appropriate materials. Don't forget naval bronze, tubing, aqualoy 17, aqualoy 19, or you can use Monel 400 or Monel 500. Those are the most common materials used and recommended for shafts. Okay, my friends, we are going to start checking the stuffing box and the flange. Remember that in a typical configuration, the transmission is located here. This is the coupling, this is the coupling, this is the shaft, this is the stuffing box, and this is the flange. In other words, this element, the stuffing box, is the element that avoid that the water enter in the boat. Remember, from this point until this is inside of the boat, and this is outside of the boat. Here we have water, and in here is inside of the boat. It's a dry area. This element is the element that avoid that the water enter in the boat. Internally of this element we have a seal. It's a special seal. This type of element is the stuffing box, and we have two types of stuffing box. We have the typical mechanical stuffing box, or we have this one, the bellows or PTS stuffing box. This one is the PTS, the typical PTS that right now I am going to explain with details. The graphite, the bellows, the PTS. Alright? And this is the mechanical stuffing box. And we are going to analyze both of them in details. Alright? The stuffing box is a mechanical seal that avoid that the water penetrate into the boat. If you disassembly, this is the typical mechanical stuffing box with seal packets. With seal packets, this one. When you open this element, you found it over there, the seal. The seal is a square. Is normally is a special fiber impregnated with a graphite like this, or impregnated with animal grease, with fat. There are two types, and there are different dimensions in this square according with the diameter of the shaft. If you check in the majority of the marine storage, you found that the different diameters according with the diameter of the shaft. And what is the procedure? You need cut it exactly the material with a razor blade according with the diameter of the shaft. And inside of this you found that three of those rings. Three of those rings are located here inside of this, exactly the same like the piston rings, separated 120 degrees to avoid leaks. You have 1, 2, and 3, and they are introduced over there inside. When you have all of them, you can tight. As soon as you tight with a pipe wrench, this one, you don't have leaks. You don't have leaks of water. My recommendation is prepare the 3 rings of the seal package. Introduce the rings over there. Tight, and always check that the system is rotating free, that the shaft is spinning with your hands. Once again, you tight, and you tight, and you tight, and you spin with your hands, and you verify that you don't have leaks. If suddenly, when you tie this one, it's impossible to turn the shaft with your hands, you need loose a little and verify that you don't have leaks. Once again, let me repeat the procedure. Can I replace those seals with the boat on the water? Yes. You need prepare the area. You need prepare conditions. You need install in the bilge close to this area a couple of bilge pumps, provisional bilge pumps. And this is the procedure. I recommend that before you disassemble the system, cut it 3 pieces of seal from the roll. You cut it 3 pieces, and right now 2 people inside verify that the bilge pumps are working properly, and you lose the system. You lose the system with the pipe wrench. As soon as you lose the system, you separate the nut and the water enter, but the bilge pumps start to work. And with the screwdrivers, you remove the old seals and you introduce the new ones. And after that, you start with the process tight and tight, and you verify that you don't have leaks. You need be prepared with the seal. Be prepared with the tools. Normally I use those type of tools to remove the old gaskets, and you need to verify that the bilge pumps be working properly, and that's it. Yes, it's very common, replace those seals with the boat on the water. This is the mechanical stuffing box and is connected into the flange. Remember that we have 2 types of flange: metallic flange like this, or flange as part of the hull in fiberglass like this. Both of them are flanges. The flange divided the dry area into the wet area. Remember, in the wet area you have water at high pressure entering in the boat. This is the procedure to repair the stuffing box. The other system of a stuffing box is the bellows. The bellows stuffing box is this one. There are different types of bellows stuffing box, but it's a bellows because you can compress this element, this rubber element. In this area, we have a bearing in a special Teflon, in a special composite materials, and we have a lip seals. This is the component. Have a bearing over there, a rubber bearing. It's a special component material, neoprene, with grooves to avoid that the water pass and keep lubricated that bearing. And this is a special composite materials, carbon fiber. If you disassemble this element, you found it. That cover, and you have a lip seal. That's the lip seal located over there to avoid that the water penetrate and enter in the boat. This is one system with lip seals and the cover over there. This is one of the systems. The other system is this. This is the element fabricated in a special composite material, and this cylinder is in carbon fiber. This cylinder will be in contact with this steel, with this color steel. It's a special stainless steel that will be in contact with this element. This one will be bolted with the shaft. This one is installed on the stuffing box. It's not moving, and this one is together with the shaft. This is spinning at the speed of the shaft because it's bolted on the shaft. This collar have 2 O-rings, like the O-rings on the screen, and this plastic element, when you tighten this one, the shaft will be together with the collar, and the collar will be spinning at the same speed of the shaft. In other words, the collar is spinning at the same speed of the shaft, and this one is attached to the flange. This is not moving, and this is moving in front of the graphite. This is a graphite, pure carbon. Remember that the graphite works like a lubricant. Okay, this element in front of the stainless steel produces a perfect seal, and the water, because you have water here, never enter in the boat because this element is under pressure. This element is under pressure. If you check, if you see, you can compress the collar. You can compress the collar, and you can attach the collar forced over there, and the water never penetrate. This is the procedure that I am going to explain right now. Can I replace my traditional mechanical stuffing box for any of those? For the bellows systems or for the PTS system? Yes, you can. It's simple. The idea is remove the stuffing box. You can remove the stuffing box, you remove the coupling, and you remove the stuffing box. Or in the other side, you remove the propeller, the strut, the flange, and you introduce the new stuffing box. We are going to install this one, the PTS. Remember, this area, the stuffing box with the graphite, is fixed on the flange. On the flange, you bolted the hose clamps, and this is the flange. This is not moving. The shaft is moving free, inside of the graphite. This is the collar of a graphite. And this is the stainless steel collar. The stainless steel collar will be bolted on the shaft. The stainless steel collar will be spinning at the same speed of the shaft in front of this graphite. The graphite works like a lubricant. In other words, I am going to approximate. This is fixed here, I tight over there, and I am going to approximate my collar over there, and I am going to press the collar. And after that, I am going to tight the collar . In other words, right now, the metallic collar is in front of the graphite, compressing the graphite. The water enter over there, but never penetrate, because in between the stainless steel collar and the graphite is produced a perfect seal. This is the PTS system. It's simple. The idea is when you approximate the collar, after that you compress, approximated ½ inch, and you tight the plastic cylinder, and the plastic cylinder keep the collar in front of a graphite, and you don't have leaks. This is a wonderful system. That system have a couple of fittings. In those fittings you can connect clear hoses. Those clear hoses are to indicate that the water is entering until this point. This is good for service. Normally you need to put this clear hose with an anti-siphon over the water line in order to verify where is the level of the water line. This is a good indicator of the level of the water line inside of the engine room. Those are the fittings to verify that the water is entering. This is the stainless steel collar that is together with the shaft, and this is the graphite that is fixed with the stuffing box and the flange. This is the PTS system. This is a wonderful system that the people use every day, more and more common. And the other one is similar to this one, but with lip seals. The lip seals is that one. Similar to this one, no metallic collar, only lip seals. And the lip seal is located here. It's located over there. After that, the collar, and after that, the cover. This one is located here. with the bellows, and this one don't need metallic color in stainless steel. Only use lip seals. This is the bellows system. This is the PTS system, and this is the mechanical stuffing box. And now we are going to check the strut, the bearings located inside of the strut. The name of those bearings are cutlass bearings. We are going to check the procedure to remove those cutlass bearings, and after that we are going to, in the next coming episode, we are going to analyze the procedure to align the system. Remember that there are boats with more than one strut, boats with two struts like this. In those boats, the process of alignment is a little more complicated, and there are boats with 3 struts. And this is the process to analyze the struts and the cutlass bearings located inside. Another vinyl component in the propulsion system is the strut. There are boats with a single strut like this, or with double strut. The strut is the element that keep the shaft aligned in between the engine and the propeller. The strut internally have a bearing. The name of that bearing is the cutlass bearing. The cutlass bearing is located here. The cutlass bearing is on place because those set screws. There are different type of set screws and different type of struts, like this. Look at this special cutlass bearing. The cutlass bearing is part of the strut. Look at the strut of this boat.
It's huge.
This is the cutlass bearing. And look at the set screws.
Set screws, yeah.
Those are the set screws to remove the cutlass bearing. And this is the shaft. Look at the shaft. The shaft.
It goes all the way in there.
And the coupling, the transmission is over there. The coupling is located here. Yep. And those are the cutlass bearing.
Put your hand in there. You can see how deep it goes.
Yeah.
You can see how deep it goes all the way in.
Right?
Wow.
The cutlass bearing, in some cases, is a big cutlass bearing, like this. And in some cases, like in the previous example, the shaft is a big shaft, more than 3 inches, a long shaft that is cut in section and is bolted one with the other one, like this. The cutlass bearing could be replaced with the tools, with mechanical tools similar to the tools used to remove the propellers. This is the tool, and the tool have a special stainless steel collars internally in order to push the old cutlass bearing and introduce the new one. The cutlass bearing is a cylinder, normally in a copper alloy, with a neoprene rubber inside, with grooves, like this one. The cutlass bearing should be replaced when the shaft have too much play with the bearing. 3/16 inches of play is enough to replace the bearing. The bearing should be wear equally. If the bearing is wear more in one side, it's because the strut is not aligned, is twisted a little. In that case, you need to remove the strut and align the system again with the procedure that I am going to explain right now in the next coming episode. The strut, the cutlass bearing is part of the strut. The cutlass bearing should be replaced each 15 years, 20 years. It's not common, replace. Probably you change the boat and you never need to replace the cutlass bearings. But when the play in between the shaft and the strut is more than 3/16 inches, the cutlass bearing should be replaced. And finally, remember that those elements are the strut, the propeller, the shaft, the bearings. Those elements are submerged in the salt water. Those elements should be protected against corrosion. And in those elements, normally you install sinks. You install sinks in between the propeller and the strut, and those sinks should be properly located in order to avoid harmonic distortions. In some boats, you have another sink at the end of the propeller and another sink on the rudder. Remember, all the metals in direct contact with the salt water should be protected with sacrificial anodes. Zinc is the preferred sacrificial anode for salt water, and aluminum, it's a special alloy of aluminum, is preferred for boats in fresh water. And also magnesium. Magnesium is a great sacrificial anode recommended for fresh water. And one common question is, what happens if I have a single engine inboard? How should be the location of that engine inside of the boat? The engine should be located in the center, aligned with the keel, with the axis of the boat? Or can I install my engine a little up? Or can I install my engine with a small angle of deviation? This is a very, what happens if I have two engines, twin engines, inboard engines? Those engines should be parallel completely or a little inclined, some angle. What is the maximum angle recommended? What is the maximum separation recommended? I follow the rules of David a.c.r in your book of Propulsion System, and those are his recommendations. For example, if I have a single engine, David a.c.r recommends that for an inboard engine, the maximum angle of deviation should be 3 degrees. 3 degrees. That's the maximum in order to avoid that the boat steer in one direction, right? This is the maximum is 3 degrees. And what about if the engine should be located parallel with the axis, exactly on the axis, or a little offset? The offset distance should be no more than 8% of the beam. That one, no more than 8%. Okay. What happens if I have two engines? What is the recommended angle of separation? The goal is to allow higher engines to fit lower in the bilge, especially in big holes. The maximum shaft angle should be 2 degrees. 2 degrees, and normally those 2 degrees, the engines facing to the center of the boat, like this. This is the maximum separation, 2 degrees. Those are recommendations that are important in the moment that you install a single inboard engine or a twin inboard engines. Okay, my friends, and now we are going to analyze the rudder. The rudder is an important element in the design of the propulsion system. The rudder comes in two basic types: inboard rudders and outboard rudders. Remember that the inboard are located under the hull and the outboards are located. An inboard rudder is almost always more efficient than the outboard rudder. Of course, it's highly efficient if the rudder is located behind of the hull. The hull traps the water rushing over the top portion of the blade, and after that the rudder receives the flow of the water coming from the propeller and steer the boat in the direction that you want. One of the $1 million question is, what is the maximum area of rudder recommended? Can I replace the actual rudder for a small rudder? Can I replace the actual rudder for a big rudder? My friends, the rudder is an element that was calculated for the engineers originally when they designed the boat, the hull, and the propulsion system. For that reason, the rudder is a vital component in the propulsion system. Never try to reduce the area, never try to replace the rudder for other with a different geometry, because you affect the performance of the engine. That hull was calculated for that specific rudder and that specific propeller. For that reason, always I recommend ask to the manufacturer. ask to the manufacturer if it's possible reduce that that rudder, that vital component. And the rudder is composed by the span, the chord, and one important factor that we are going to take in consideration when we design rudders is the aspect ratio. And the aspect ratio is the span squared divided by the total area of the rudder. It's difficult to calculate the total area of the rudder. No, you can divide it, the total area, in triangles and rectangles, and you added those areas in order to calculate the total area. Don't forget, the aspect ratio should be the span squared divided by the area. This is the magic formula in order to calculate the aspect ratio. And this is very important because according with the aspect ratio, you can select the appropriate rudder for your boat. For inboard power boats, the aspect ratio should be in between 1.9 and 2.4. This is the acceptable number for aspect ratio for inboard power boats. An aspect ratio higher than 2.4 give a still more efficient rudder blade, but added excessive bending strains on the rudder stocks. Okay, be careful with that. In sailboats, the situation is different. The aspect ratio on sailboats are in between 2.2 and 3.5. Those are the most common. Very high aspect ratio in between 3.5 and 4.5 are becoming with the hulls that the fin and the keels are together, like this hull. Right? What happened with the rudder? The rudder, in the shaft of the rudder used a same stuffing box, exactly the same stuffing box used in the propulsion system on the shaft. Normally, the stuffing box located on the shaft of the rudder is the mechanical stuffing box with the seal packets that I explained to you, the procedure to replace that package. Yes, this is another element where it's possible that the water penetrate and enter in the boat, in the hull. Remember, there are different areas where normally the water penetrate in the hull. One is in the stuffing box of the shafts, other one in the stuffing box of the rudders, or on the through hulls. The through hulls, the different type of through hulls. If the through hull is improperly installed, probably water penetrate and enter in the boat. In the first chapters of our course of auxiliary systems, I am going to explain the procedure to do the hull and install through hulls in order to avoid migration of water inside of the boat.